Did I tell you that if you say, if you have a fraction 2 all over x plus 2, x plus 3. Please look up, class. To break this guy into partial fraction, you're going to say a, right? All over x plus 2 plus b all over what? X plus 3. What if you add 2 all over x plus 2, x plus 3, x plus 4? Class, I told you that the number of denominator you have determines how many partial fractions can be gotten. Class, this is going to be equal to a all over x plus 2 plus b all over x plus 3 plus c all over x plus 4. Do you get the idea, class? The number of denominators you have will also determine the number of partial fractions you will. Even if this were to be 4 factors, class, it will be a all over this, b all over this, c all over this, plus d all over. You will now have to resolve all of them and get a, b, and c, or a, b, c, and d. So sometimes, class, partial fraction questions could lead to several, like step-by-step, a long method that you might take you simultaneous equation of 3 unknown, as the case may be. So please take note of that. So, but for, I think for university level, 100 level, this might be the limit they might go. But please be informed that it's possible to have more factors. It's very possible to have more factors. Please take note. Now, this is just linear factors, remember. Remember, we said we have 3 classes of partial fractions. Now, I quickly want to show you what we would have done if it was the second classification. Please come here. Look at this. If it were to be these partial fractions with repeated linear or quadratic factors. How do we deal with partial fractions with repeated factors? What do we mean by repeated factors? Look at this. 2 all over x plus 2 and x minus 1 squared. Class, x minus 1 squared means that x minus 1 is repeated, right? Because it's not occurring once, occurring twice. This one by repeated factors. Anytime one of the denominator is carrying a square or a cube, is a repeated factor. It's a repeated what? How do we undo partial fractions with repeated factors, class? Let me use this. Let me assume that we have 2 all over x plus 2. Class, look up, please. It's important to understand mentally first what you write in your book. Your brain is going to the exam, your book is not going to the exam. So store things in your brain first, class. 2 all over x plus 2 and x plus 3 square, right? How do you undo this, class? Look up. Class, you're going to say a all over x plus 2. Are you seeing it? Plus b all over x plus 3. Don't put square. Don't put square. Now plus c all over x plus 3 square. These are your undo squared partial fractions. A all over x plus 2. Now plus b all over x plus 3. Class, you assume the square is not there. Just say b all over x plus 3. Then you now come again and say plus c all over x plus 3 all square. When we come for math class, I'll still calm down and teach all these things. But I want to just find a way to link us to the assignment first. Are we together? There are a lot of things that I can't do now, but I'll make sure. I'm just trying to make sure that I understand partial fraction a bit before I solve the assignment. So class, because there are some partial fractions actually, let me just shock you now. Partial fractions that will require you to do long division of polynomials first. Now let me tell you something. It's an error for, if they give you a partial fraction, x raised to the power 3 all over x minus 1. Class, and you have to decompose this guy into partial fraction. Class, is an error, is a taboo for your numerator to have a higher power than your denominator. Class, I will first do long division. I will say x raised to the power 3 divided by x minus 1. So there's a part of partial fraction that might even require you to do long division. And let me shock you again, class. That assignment, that manual in the workbook requires long division. Requires what? Yes, the first one requires long. You see why they teach you polynomials first before partial fractions. Now, someone can ask me again, sir, what if these two factors are both squared? What will happen? Class, look up please. Everybody please look. 2 all over x plus 2 squared and x plus 3 squared. Now, those of you watching this video online, I know you didn't come to class and you're watching this video. You need to be in class. You see the things you're going to face in your exam. Are you seeing what you're going to face in your exam? So don't just depend on YouTube video. You must come to class. I'm just doing this video for you because I know some of you, maybe you're staying far. You couldn't make up Saturday class. But make sure you're coming to class. Look at what they're planning for you in the exam. Now, how do we undo this? 2 all over x plus 2 squared and x plus 3 what? Squared. Class, if the two factors are squared, what do you do? Please look up. You're going to say a all over x plus 2. A all over what? Now plus b all over x plus 2 squared plus c all over now x plus 3 plus d all over what? X plus 3 squared. Plus, as long as this is, you get answer for A, B, C, D. In our normal class during the week, I'll teach you how to now get the answer. But I want you to know how to this, to add the foundation of partial fraction. This is how you resolve this kind of partial fraction. This is a partial fraction of repeated factors, right? Let's now go to the third classification of partial, which is the last one, and I'll solve the assignment. The last one is partial fraction C. Partial fraction with quadratic factors. Partial what? With what? Quadratic factors. Partial fraction with quadratic factors. Please pay attention carefully. Class, look at this partial fraction. 3x minus 4 all over 2x minus 3 into bracket x squared plus 5. Class, anything that makes one of your x inside the bracket to carry a square, you are dealing with a quadratic factor. You're dealing with a what? What's the difference between 2x? This 2x minus 3 is linear. Are you seeing it? But x squared plus 5 is quadratic is what? And there's a rule for solving quadratic factor. Class, this linear factor, you give him a all over 2x minus 3. This is linear, right? Now for the quadratic, you're not going to say plus bx plus c all over the quadratic factor, x squared plus what? Bx plus c all over what? Notice that I gave this linear factor a, just a, right? But the quadratic factor, I gave it what? Bx plus c all over x squared plus. This is how you resolve quadratic factor. This is how you resolve what? Quadratic factor. Now let's go to the assignment. Watch out for the next video for the assignment. Let's now go to the assignment.